Hello. While a lot has changed with this project, I want to pick up where I left off from the first devlog and just briefly talk about the idea of this game. There's a lot to talk about in this devlog compared to the first, so I'm going to try to keep it short, but I do have a small problem when it comes to rambling. Hello. So in this short tutorial video, I wanted to show off a few different examples that I've made on how you can procedurally change the material of instances with geometry nodes. That video was an hour long. So not to waste any more time, here is the idea for the game. Two things that I started to notice in my daily life was the gig economy and robots. The game is grounded on the idea that in the future, humans will be paid to pilot robots remotely from their homes to complete small jobs or gigs. The gameplay will involve you or a group picking jobs to complete, earning money from said job, and then using that money to purchase upgrades, then returning to select another job. The jobs act as rounds, with each round having their own quota that needs to be completed in a set amount of time. You and your team, if you complete the quota, will be rewarded with money. If you fail to meet the quota, you will lose and the game will end. The point is to see how many rounds your team can complete before you inevitably lose. The player experience should feel like you're playing a bunch of fun little small mini games wrapped into a puzzle where you need to work as a team to correctly complete jobs and spend money. With the majority of my code and mechanics out of the way, I've finally been able to start level designing. The first level I began working on is set in the back room of an airport with conveyor belts that are carrying suitcases. Level design isn't something that I've spent a lot of time on, so after making a simple block out, I started searching online for helpful resources to improve my level from this to this. While there are a lot of great sources you can find, my personal recommendation is Spatial Communication in Level Design by Peter Field. Coming back to Unity, with a better understanding of level design, I moved away from the boring box and added in walls to create a more unique shape, which really helped the overall feel. With the shape done, I needed a good color palette, and I made sure to be smart about finding one. With a strong color scheme, I jumped between Blender, Substance Painter, and Unity, updating my scene, adding in texture, giving my scene a much more improved look with each addition. I added light. I greatly reduced the light. I added polish by adding animation for my conveyor belts. Everything was going well until, from starting out as a simple shape and rough blockouts, this project was starting to really take shape, and the more I added, the more I was enjoying level design. I felt like I was finally able to really start working on making this project a multiplayer game. Now, when it comes to game design, these guys are my friends. I like these guys, not those guys. And while I don't like those guys, the one I want to talk about specifically is Unity's Profiler. In Unity, you're able to see the performance of your game, see the pressure it puts on your GPU, CPU, and look through graphs that break down the rendering, animation, and code compiling time, which all boils down to your performance and FPS. Now, making my project optimized is important because I'm a game designer. I'm trying to make a game, I'm not trying to make a colorful bomb. While I worked on building my level, I was also working to keep my game optimized. The first area I tackled was with my character script. The improvement I made was caching my Git components. There are a lot of ways to improve your optimization, but it all boils down to your computer doing math and finding the best way it should be doing that math. I spent about a day diving deep into memory allocation and learning how it's stored. And this process felt like hitting a brick wall. It greatly slowed down my progress on the rest of the project, but it was necessary so I didn't have to fix optimization later on. Still, there's a lot more I need to learn, and while it's boring, it's important to talk about for this project because memory allocation is extremely important in multiplayer games. And while it's most likely that a lot of people won't have to do or learn about memory allocation, it's important to know that this exists because someone in your project will have to worry about it. The simplified version of it is that there are two key pieces, the stack and the heap. They work together to store memory, but they both handle different value types. The stack handles variable types like ints, bools, vector 3s, vector 2s, and the heap stores reference types like objects, arrays, lists, and the components connected to those objects like the animator, rigid body, and transform. The stack is fast and can handle quick math. When you run a function, a local variable is stored on the stack, and when the method finishes, that information is thrown away instantly to free up memory immediately. The heap is where objects are stored. It doesn't delete memory and will hold onto an object until they are destroyed. When an object is destroyed, it becomes garbage and will need to be cleaned up, which can have an impact on the performance. The heap is necessary for objects that need to constantly make calls across methods, be shared between multiple references, or have dynamic sizes. Using my script as an example and why it's bad is I had a character and the character had an animator. The character needs to tell the animator how fast they're moving to play the right animation. For this, I need to have a pointer to find where the animator is to send that information. I had my pointer living on the stack, which is bad because that means every frame, every single time my script runs, it's constantly trying to find the animator again. What I changed to improve it was have the pointer live on the heap, meaning that I now have a pointer that always knows where my animator is and will live until I no longer need it. Now, that's probably a little confusing, so my analogy for this process is the heap is a pile of papers on your desk, and the stack is a whiteboard. On the whiteboard, you write small math problems quickly, then erase your math to free up space on the board for the next problem. The pile of papers is another place you can do math. You take a piece of paper, write down a formula or big math problem, and then you can save it for later on your desk. At some point, you might finish with that piece of paper and can throw it away. With papers on your desk, you can also look at them or reference them while doing math on your whiteboard. There's a lot more that can be talked about with the profiler, and if interested, I can always make another video talking more about what I did to improve my game's performance. But to summarize for people who aren't interested in the super awesome stuff, I also improved my scripts by making all physics math run on fixed update instead of update, so it's not happening every frame. I had the number of rigid bodies in my scene decreased, and I added baked lighting to the scene. This turned my performance from a struggling 60 FPS to a comfortable 200 for when I add in more players. With my scripts complete, character with animation and mechanics, a scene with 3D modeled assets and texture maps, I was finally able to start playtesting and understand that I had to stop with this game. While I wasn't happy about tossing this project, it was through playtesting that I was able to see holes in this idea that I couldn't see before. The two main issues was one, the scope. I had finished one of the levels, but the game itself was going to have 4 to 6. And even after creating these levels, there was an issue with balancing. The issue I had with balancing was between upgrades and levels. If I wanted to have a large amount of unique levels, I would need a large amount of upgrades to support each of the challenges those levels face for the player to be able to buy and progress. If I wanted an easier time balancing my upgrades, I would in turn need to have the levels be more similar to each other, which would be boring if the overall gameplay wasn't enjoyable. While I did spend a lot of time on this project, it wasn't for waste. I learned a lot more about game design and good practices, and the scripts and models I made can be stored away for later use. I decided to take a break from the project. I hadn't given up because working on this game is better than doom scrolling with my free time, but I needed to rethink the idea. Spending some time away, relaxing, playing video games helped me think of a new idea that solved a lot of the previous problems, while keeping a lot of the same mechanics and themes. With the original idea of the game shelved away, the new direction of the game will be taking place on an alien planet where you harvest ore for a company that is growing this ore at the core of a planet in a farm style environment where you will be operating robots to collect it because the environment is too hot for humans. At first, I was trying to come up with new ideas for mini games for the original project. The idea that I came up with was a mini game where you were trying to cook pizza using lava as a heat source. If this is something you want to use, feel free to use it. But the idea of the game was that you would have to periodically move pizza forward and backwards to make sure it stays near the lava to cook it, but never falls into the lava and gets burned. From this idea, I started thinking about volcanoes to ore to mining, and eventually worked my way down to this idea of a game where you're harvesting ore. The main gameplay stays the same as you're still a group trying to complete levels that have quotas and a set amount of time. But instead of moving to a new level or map each time you finish a level, you're constantly returning to this home or farm so you can feel like you're able to improve or build on this area. The gameplay is strategy plus resource management, grounded with controls that are very easy to understand. The simplified version of the gameplay is that you are collecting ore to sell ore and to complete a quota each round. The current progress again starts with mechanics. My current scripts allow me to pick up items and have them stored in a backpack system. I can then use my scroll wheel to shoot out an item I select from the backpack. The shooting mechanic will play a big role in interacting with different areas. For example, the area to deposit or sell ore can be reached by walking over to it, but players will save time by shooting the ore at the area instead of spending time walking over. Since you are farming ore, a component I plan to add are silos. The core pillar of this game is that the quota system, which if failed to complete, will end your game. The silos will allow you to store your ore or materials for future rounds as almost a safety net that you can pull from. A concept that wouldn't have worked in the original version as you moved from place to place and it felt like you restarted every level. Another benefit of this current project is having a smaller scope, which allows making balancing a lot easier with upgrades. Without having to worry about different challenges, I can just focus on making producing ore easier for the player when they choose to spend money. These upgrades paired with silos create a strong dynamic where players can now save their resources in silos for future levels or sell them as money and invest into improving their production in the long term. This is the current state of my game. It will be a little while before I can actually start thinking of adding in multiplayer and server hosting again, but at the moment, the next step I have is to add in a few more gameplay components for the player, having a few more 3D models and textures to make the main area look a little bit nicer, and then again starting the playtesting experience. If you have any questions or suggestions, feel free to leave them. I'd love to read them. And thank you again for listening to this devlog. I hope you enjoyed.